Hi, today we're going to be talking about section 3.8, derivatives of inverse trig functions. We'll be looking at some of these, and it really is just a matter of memorizing them. So if you're not a memorizer, get some flashcards out or something so that you can memorize these for your test, because we do need them memorized. They will be on your AP test. So to start off with, if any function f is differentiable at any point on an interval I, and the derivative of f with respect to x is never 0 on that interval, then f has an inverse. And the inverse of f is differentiable at every point on the interval f of I. Okay, so basically just saying, as long as a function doesn't have a horizontal slope at any point along that same interval, its inverse is also differentiable, which would make sense, because if it was a horizontal line and we reflected that over the y equals x line, it would be a vertical line, and then there would be no derivative there because you'd have a slope of or an infinite slope. Okay, here's the inverse functions you'll need. You'll need inverse sine, inverse cosine, inverse tangent, inverse cotangent, inverse secant, and inverse cosecant. If you'd like to see how these are proven in your book, feel free. I'm not going to take the time to do that, but it is kind of nice to see sometimes where these come from. So, inverse of sine is 1 over the square root of 1 minus x squared. Inverse cosine is the same thing except for it's the opposite. And notice, just like when we did inverse sine, the inverse of sine is positive cosine. The inverse of cosine is negative sine. Well, notice that anything that starts with a c has a negative sign in front. So the identities are pretty much the same except for just opposite in sign if you're talking inverse sine compared to inverse cosine, or inverse tangent compared to inverse cotangent, or inverse secant compared to inverse cosecant. So really you only would have to memorize these first 3, and then you just need to know that if sine is this, then, or the inverse of sine is this, then the inverse cosine is just opposite of that. So that might help a little bit. Okay. Also wanted you to take a look, just thinking about how you would translate these on a graph. The inverse of cosine is the same thing as pi over 2 minus the inverse sine function. Same relationship for cotangent, cosecant. It's pi over 2 minus the tangent, or pi over 2 minus the cosecant. So that would be like a translation on your, if you were to graph these functions. Okay. Because your calculator doesn't have secant, cotangent, or cosecant, you will need, if you want to use them on your calculator, to know these identities, where the inverse of secant is equal to the inverse cosine of 1 over x. The inverse cotangent is equal to pi over 2 minus the inverse tangent of x. So we already saw that one from the previous one. And then the inverse secant is equal to the inverse sine of 1 over x. So that will help you when you are trying to check things with your calculator. Alright, the best way to do this is just to dive right in and give these a shot. So I want you to hit pause, go back and see if you can use the identities of what inverse cosine is equal to, and then see if you can figure out what the inverse of cosine of 1 over x would be equal to. Go ahead and hit pause. One way you can think of this is by using one of those identities we just saw and say that the inverse cosine of 1 over x is equal to the inverse secant. The inverse secant of x. And then I know that the derivative dy, well, maybe not dy, just the derivative with respect to x of the secant, or inverse secant of x is equal to 1 over the absolute value of x times the square root of x squared minus 1. Another way you could do this is just to do, knowing that the derivative of the inverse cosine, and kind of use the chain rule, is equal to 1 over square root of 1 minus x squared. It's cosine, so it's got to be the negative one. So, except it's not x squared, it's 1, let's see if I can draw this in here, 1 over x squared. Okay, so that's the derivative of the outside, there's the cosine of that, times the derivative of the inside. And the inside is x to the negative first, so we could make this a plus, and then this could be times in x to the negative second power, and you could move that down to the denominator and maybe simplify a little bit more from there. So kind of two ways you could do this one. I think most people will use the trig property to get that first answer, just because you want to be able to recognize that the inverse cosine of 1 over x is the same thing as the inverse secant of x. So that would probably be the more common answer. Okay, I'm going to have you try one more just to see how you do with this. So hit pause and see if you can find the inverse or the derivative of y here with respect to, I know that says with respect to x, so sorry, that should say with respect to s. So let me change that to an s. Hit pause. Okay, well, just like the last one, we know the inverse of secant, or the derivative of the inverse of secant of x is equal to 1 over the absolute value of x times the square root of x squared minus 1. But we don't have x, we have 5s, so it's going to be the same thing pretty much, except it'll be 1 over the absolute value of 5s times the square root of 5s squared minus 1, so that's the derivative of the outside, leave the inside alone, times the derivative of the inside. Well, the derivative of 5s is just 5, so we can change this 1 up top to just be a 5 up there, and that should be our right answer. Okay, so there's not a ton to, I mean, really this is another one of those that we just have to practice. So we got to memorize these rules and then just practice them as much as we can so we can remember them a little bit easier. I wish there were more tricks other than memorizing for you, because I know for me memorizing is tough, but you guys are going to rock and roll. So good luck. Bring in questions you have from class, or to class. Thanks.